everyone, my name is Jane. I am the primary investigator of this research study. Today, we're going to have a mini chemistry lesson. Missing chemistry from high school? We're going to pick it up right now. As you can see from here, I have two beautiful molecules on my desk. We're going to learn two things about these two molecules. Number one, what is an R and S configuration naming system? Number two, how to tell if a molecule is R or S. Okay, so right now I'm gonna give you 30 seconds so that you can play with these two molecules. After that, you're gonna let me know what's interesting about these two molecules. Do they look the same? Are they similar? Do they look the same but different from each other in a certain way? You do not have to stop the video during the time. I will let you know when the time is up. Yes, as you have found out, these two molecules are mirror images to each other. They have exactly the same functional groups, but of different structures. Their functional groups are the green one, the white one, the red one, and the black one. These two molecules are not superimposable, just like my left hand and my right hand. By not superimposable, I mean no matter how I rotate my two hands, I cannot put them together in a three-dimensional space. Just like I cannot put my left hand into the glove of my right hand. For this kind of molecule, we have a specific naming system for them. It is called the R and S configuration system. So one of these two molecules is R, the other of them is S. In order to know which one is R, which one is S, we have two steps, to rotate and to count. Before we rotate, just as we know, as you can see from here, we have the numbers here assigned to the functional groups, 1, 2, and 3. These numbers are assigned based on the functional group's molecular weight. By that we mean the heaviest functional group gets the number 1, the second heaviest gets number 2, the third heaviest gets number 3, and the lightest gets the number 4. The same for this molecule. And then in order to know which one is R, which one is S, firstly we rotate the molecule so that number 4 is pointing away from us. The same thing here, we rotate so that number 4 is pointing away from us. And then we count 1, 2, 3. If this one is counterclockwise, we call it S. This one is clockwise, we call it R. This is how we use gesture to decide which one is R, which one is S. Conventionally, we use this wedge and dash notation to represent these two molecules. Conventionally, we use this black solid line to represent functional groups that are on the plane of this board, just like this and this. This black wedge here means that this functional group is pointing toward us, just like this one. This dash means that this functional group is pointing away from us inside this board, just like this black one. So this one is a representation of this molecule. Here, I want you to do it together with me using gestures. Let's put our hands and let's do it together. I will always use my arm to represent the functional group number 4. So 4 and 2 are on the same plane. They are on the plane of this board. 3 is pointing toward us. 1 is pointing away from us. So 1, 2, 3, 4. We got 1, 2, 3, 4 in my hand. To decide if it is R or S, I will rotate my molecule so that 4 is pointing away from us. Okay, and then we count 1, 2, 3. 1, 2, 3, 1, 2, 3. If it is counterclockwise, we call it S. If it's clockwise, in other way, we call it R. Just like this. This is a very brief review of what we have just learned today. First one, the wedge and dash notation. Black solid lines. These two functional groups are on the plane of this board. Black wedge, this functional group is pointing towards us. The dash, this functional group is pointing inside the board and pointing away from us. On the plane of the board, pointing towards us, pointing away from us. Secondly, the molecules. In order to decide which one is R, which one is S, we rotate the molecule so that number 4 is pointing away from us. Number 4 is pointing away from us. And then we count 1, 2, 3. 1, 2, 3. If it is counterclockwise, it is S. If it is clockwise, it is R.